here's an absolute value inequality in one variable. That looks a little tough, but it really isn't. So if we just remember, we're looking for the absolute value to be by itself. So that whole thing is the absolute value. So we're going to apply what we know about GEMDAS. We're solving, so we're going backwards, which means that the first thing we're going to do is we're going to ask, is anything being added or subtracted from the absolute value, whatever that is. And we can see right here we have the absolute value has something being subtracted from it, which means we're going to add that 6 so that this turns into a 0. So then I'm left with 3 times the absolute value of the quantity x minus 3, all divided by 2, is less than 12. So then the second question I ask myself, is anything being multiplied or divided? I should say to, not from, to the absolute value. And the answer is yes, that 3. So we're going to divide that 3 out of there. So then I'm left with the absolute value of the quantity x minus 3, all divided by 2, which is less than 4. So now that I have my absolute value all by itself, I have to do that first, I can then set this up into case 1 and case 2. So I'm going to write case 1, which is my as is, and my case 2, which is my opposite. So case 1, the quantity of x minus 3 over 2 is less than 4. Now the opposite of this is I have the quantity of x minus 3 all over 2, and I have to do the opposite of that, which is negative 1, and that's going to be less than 4. Okay, so let's do case 1 first. I want to get this 2 out of the denominator. Notice everything here on the top, this is all on the top. So this is one big number divided by 2. So in order to get that 2 out of the denominator, I'm going to multiply by 2 in the numerator, which is the same as 2 over 1, because this becomes 2 divided by 2, which will divide out to 1. I multiplied a 2 on the left, so I have to multiply a 2 on the right. So this 2 divided by 2 divides out to a 1. So then I'm left with the quantity of x minus 3 is less than 8. Add 3 to both sides, and I get x is less than 11. So over on this side, and it's gotten a little bit crazy here, so I'm going to put this line like this. Over here on this side, I'm multiplying a negative 1. Well, you could distribute that negative 1 in, but I recommend, why don't we either multiply or divide that negative 1 out. We're going to do it to both sides. It will just make it a little easier, because this is negative 1 times one number here. That parentheses is the one number. So let's go ahead and do that. So I'm going to divide negative 1 by negative 1, then everything on the right side by negative 1. So negative 1 divided by negative 1, that gives me simply 1, which means now I have x minus 3 over 2. I've divided by negative, so I flip my inequality, negative 4. I want to get this 2 out of the denominator. So that means I'm going to multiply, just like I did over here. I'm going to multiply a 2 in the numerator. So 2 divided by 2 is simply 1. That divides out to 1. So now I'm left with x minus 3 is greater than negative 8. Then I'm going to add 3 to both sides. And then I get x is greater than negative 5. So I have two answers. I have x is less than 11, x is greater than negative 5. So let's put those values there. Negative 5 is over here, 11 is right here. It cannot equal either one, so I'm going to put an open circle. So x less than 11, well this is 11, 10 is less, so that's everything this way. X is greater than negative 5, well negative 5 is here, negative 4 is bigger, negative 3 is bigger, so that's everything this way. So it's in between. So another way that you can remember is that if we look here, let's look right here, and I'm just going to read that. The absolute value is less than. Okay, so I'm going to read that as less than. I'm not going to read all the stuff inside the absolute value because then it just gets confusing. So the absolute value is less than. This is an and problem. 90% of the time, our and problems are going to be like this. Pretty much as far as this Algebra 2 course is concerned, I'm going to say they're always going to be like this. That means my x value is in the middle. So it's in between, any number in between, negative 5 and 11. It could be negative 4.4968. It could be 0. It could be 10.999. It can be anything in between. Okay, that's what this line means. So for set builder notation, we have to do it as such. Well, let's look here. I know negative 5 is less than 11. So my symbol, my inequality, has to go that way, because negative 5 is less than 11. 11 is bigger than negative 5. My x is in the center. If you have these not facing the same direction, you did something wrong. Bottom line. So the set of x such that negative 5 is less than x is less than 11. That's how we would write it. So for interval notation, we're starting where? We're starting at negative 5. It cannot equal negative 5. And it includes every single possible number up until we hit 11. But it cannot equal 11. So I know this looks like a coordinate, but it's not a coordinate. And we know it's not a coordinate because I'm talking about the interval. So this here is an interval. And it's from one place to another. Okay? This is not a point. Just want to stress that with you. It's not a point. It's an interval. So if you think of interval, it's like interval training. So maybe I'm just walking, and then I come here, I'm going to sprint that entire time, and then I stop sprinting and I walk and walk. So the interval I sprint is from negative 5, if you could have such a thing, all the way to 11. So I just want you to keep that in mind.